It is given that an observer and a vehicle both starts moving together from rest with an acceleration of 5 meter per second square and 2 meter per second square respectively. There is a 2 kilogram block on the floor of vehicle and coefficient of friction is given as 0.3 between their surfaces. Find the work done by the frictional force on 2 kilogram block as observed by the running observer during first 2 seconds of its motion. So basically for the calculation of work done, we know that we'll use the equation work done is equal to force into displacement. Yeah, F into S into cos theta or F dot S. So we need to find out what about the value of frictional force acting on the block, as well as we need to find out the value of displacement of that with respect to the observer. So because we are going to find out the work done with respect to the observer. So first we need to find out whether this block is going to slide on the surface or not. So over here just assume that an observer is on the car and this observer is in a frame of reference which is moving with acceleration which is given as 2 meter per second square. So we can say that there will be a pseudo force acting on the block towards left with respect to an observer on the accelerating frame of reference, and that pseudo force is equal to mass into acceleration of reference frame, that is 4. So as the block is trying to move towards left with respect to the car, then frictional force will act towards right, and the frictional force we can find out by using this equation mu into normal reaction, which is equal to mu into mg. So which will give the maximum possible value of frictional force. So the maximum possible value of frictional force is mu is 0.3 into mg, m is 2 and g we can take it as 10. So this will be equal to nothing but 6. It can exert up to 6 Newton force. But the frictional force required to stop this block is only 4. So frictional force going to act as 4, not 6. The frictional force acting on this one will be equal to 4, so that this block will be at rest with respect to the car. Now this car is moving with an acceleration of 2 meter per second and the block is at rest with respect to the car. So we can find out what about the value of displacement of that block with respect to ground. That we can use that equation as is equal to ut plus half at square. Initial velocity is 0 and acceleration is 2 and time is 2 seconds, so 2 square 4. So we can write this will be equal to 4 meter. Now we can find out what about the displacement of observer. Observer is moving with an acceleration of 5 meter per second square. So its displacement, again if you are using the same equation, we'll get as half into a is 5 into t square, which is 4. So its displacement is 10. So we can find out what is displacement of block with respect to observer. That is displacement of block minus displacement of observer. Displacement of block is 4 minus displacement of observer is 10. So we'll get the displacement of block with respect to observer is minus 6. Now we can find out, or already we discussed about that frictional force acting on it is 4. So we can find out what about the value of work done, which is force into displacement. Force is basically 4 and displacement is 6 in opposite direction. So work done will be equal to 6 into minus 6 into 4, which is equal to minus 24.